Solving quadratic equations, lesson 1. This lesson will focus on describing the relationship between the roots of a quadratic equation, the zeros of the corresponding quadratic function, and the x-intercepts of the graph of the quadratic function. Solving quadratic equations by graphing the corresponding quadratic function. Ax squared plus bx plus c is an expression that we simplify. Because there's no equal sign, we can't solve it. We simply simplify it. Y equals ax squared plus bx plus c is a function that we can graph. When we have that function being equal to 0, we now have an equation that we can solve. When we graph a quadratic function, we see the x-intercepts where y equals 0. We call these zeros of the function. When solving the corresponding quadratic equation, the solutions are called roots. So let's look at an example. The quadratic equation 0 equals negative x squared plus 8x minus 16 can be solved in many graphical ways. We can graph this function. Notice that our only difference is the function is y equals rather than 0 equals. This is in standard form. In last unit, we learned to convert from vertex form and graph with our knowledge of A, P, and Q. We can use a table of values and then graph. We can use technology such as a TI-82 calculator to graph. Once we've graphed our function, we'll see that the x-intercepts and therefore the solutions. So let's have a look at that graph. Here's the graph of that previous function. Our x-intercept is this point here, which is the point 4, 0. That point is the x-intercept. It is called a root. It is also the solution to the equation. The solution would be the point when x equals 4. So the x-intercept, the root, and the solution are all x equals 4. Let's look at another example. There's two more graphs. In graph A, how many roots or solutions does this graph have? The root or the solution occur at every point where our graph crosses the x-axis or at every point where y equals 0. So this one has two roots. Those roots are x equals negative 2 and x equals negative 1. Graph B also has two roots. One at x equals negative 3 and a second at x equals positive 3. Solving quadratic equations by factoring. We want to look at a method other than graphing to allow us to solve quadratic equations. Some quadratic equations are easily factored. We're going to use something called the zero product property. It says if the product of two real numbers is 0, then one or both of the numbers must be 0. So if A times B equals 0, then either A or B or both are 0. We're going to factor quadratic equations, set each factor equal to 0, and then solve for the root. So example number 1, 3x squared minus 2x minus 5. The first step is to factor this polynomial. So again, I can use my box method. In the box method, we'll have 3 and 1 as factors of 3, and negative 5 and 1 as factors of 5. 1 times negative 5 is negative 5. 3 times 1 is 3. Adding is negative 2, which is what I want. So if I factor my polynomial and leave it equal to 0, my first factor is 3x minus 5. The second one, x plus 1. Remember that I'm looking for the points where y would be 0, or those x-intercepts. I can find those by taking each of these factors and making them equal to 0. So 3x minus 5 will have to be 0, and or x plus 1 will be equal to 0. Let's solve each factor. Adding 5 to both sides gives me 3x equals positive 5. Divide both sides by 3 gives me x equals 5 over 3. Our second factor, I'm going to take away 1 from both sides, and I get x equals negative 1. This means that if I was to graph this quadratic function, my a value is positive, so I know that it opens up, that it would cross the x-axis at these two values. So it would cross over here at negative 1, and on this side at 5 1/3. So my solutions are x equals negative 1 and x equals 5 over 3. Next, we're going to solve those equations, and then we're going to verify that our solutions are correct. So solving this one, we can use our box method or another method of your choice. And we're going to factor. This will factor into x plus 3 and x plus 3. We're going to make each factor equal to 0. This time it turns out that both of our factors are the same. Solve them for x. So subtract 3 from both sides, and we get x equals negative 3 from both factors. I can verify this. To verify, I want to substitute in the value that we found for x into our original equation to show that the left side and the right side are equal. So on the left-hand side, instead of x, I'm going to put in negative 3. So I have negative 3 squared plus 6 times negative 3 plus 9. And I want to show that it equals the right-hand side, which is 0. Negative 3 squared is 9. 6 times negative 3 is minus 18. Plus 9. This side simplifies to 0. So the left-hand side equals the right-hand side, and I verified this equation. The next one, again, step 1 is to factor. This will factor into x plus 7 and x minus 3. The next step is to set each factor equal to 0, and then solve the equation. Our first one will be x equals negative 7. Our second solution is x equals positive 3. When I'm verifying, I want to verify both answers if there's more than one. So verifying that x is equal to negative 7 means that I'm going to substitute in negative 7 for x. Negative 7 squared plus 4 times negative 7 minus 21. And I want to show that it is equal to 0. Negative 7 squared is 49, minus 28, minus 21 is equal to 0, and therefore that solution is verified. I want to verify my second answer as well. So I want to verify that x equals 3. X equals 3, I have 3 squared plus 4 times 3 minus 21, and I want to show that it is 0. 3 squared is 9, plus 12 minus 21 is indeed 0. Often our solutions are written as a solution set. Our solution set in this case are the values of negative 7 and 3. If we go back to the first example, our solution set is just the value of negative 3. Let's do one more. Again, factoring, I can use the box method. and determine that my two factors are 2x plus 1 and x minus 5. Setting each of those factors equal to 0, and then solving those equations. This one, if I subtract 1 from both sides, I end up with 2x equals negative 1. Divide both sides by 2, and I have x equals negative 1/2. On this side, x, adding 5 to both sides, I get x equals positive 5. Again, to verify, I want to substitute both of those back into my original equation.